Okay, I've jumped to a different paper because the 2019 that we were looking at was a wee bit odd with the last question. But typically, the last question is a graph question. Even the 2019 was a graph question, which is a little bit different. So, there is no excuse for not getting decent marks on the last question. It's the same in most of them, that you can just go through them all and practice and practice and practice till you get it. So, you are presented with a results table. In this case, it's for a pendulum that's been swinging. And what they're doing, look, is they're changing the length of the pendulum and measuring the time, but they've recorded time squared. And note, the units are seconds squared, therefore. They've given you a formula. It looks a little bit weird, but there's a reason for that. And then they've given you an instruction. Part A, draw your graph. 3 marks. This is worth 3 marks. So remember, you're chasing those 3 marks. So let's look at the graph. It seems a bit strange the way they've put graph paper miles away, but that's because they've got the graph paper on the left of the book and the results table on the right of the book, so you don't have to keep flicking. Right, you've got your graph here. You are chasing 3 marks. So look, I have the labels here, length in meters and time squared, so that'll be in seconds squared as we mentioned earlier. And then my scales, look at my scales, I've gone linear here. And you're always better to go up in 1s, 2s or 5s, or their orders of magnitude. So in this case I've chosen across the bottom to go up in 2s, 0.2, 0.4, 0.6, 0.8, and I've kept the scale linear whole way up. Every box is worth the same. Up the side, exactly the same. Watch that first box. I could have a 0 in there. I haven't drawn it in, but that's okay. Up the side here, I've gone up in 0.5s. Yeah, so be really, really careful about your scales. So that's, you got 2 marks already. And then your points. So little crosses. Make sure that you're accurate to within half a box, half the smallest box. And watch your numbers, especially with this one. Look, they've been a wee bit awkward. Because look, you might expect that one to be 1, but they've actually done it as 1.1. So be careful with your points. Best fit line. You need to draw a best fit line that gets close to all the points, and you're aiming for about the same above the line as below the line. So that's your last mark, your dots in your best fit line. You can extend it back if you want. That's okay, you don't have to. And I know in chemistry they say do not extend beyond the limits of your results. But in physics, it's actually can be quite good to extend. Do not force it to go through 0. Even though you expect it to go through 0, do not force it to go through 0. This one, to me, looks like it would go through 0. Okay. Right, next thing. They'll ask you to find the gradient. So, you can either do your y2 take y1, x2 take x1, or your vertical over your horizontal. So I know a lot of boys and girls like to draw a vertical line down and a horizontal line across, and just do your gradient as vertical over horizontal, and that's okay. But remember, if you're doing that, your boxes are worth different values on each side. Right, choose 2 points that are on your line. They have to be on your line. You're finished with the results table. It doesn't matter to you now. You're choosing 2 points that are on your line, and choose points that are easy. Had I extended this all the way back again, had it gone through 0, not forced through 0 again, but had it gone through 0, that's obviously a nice easy point to choose. And then you choose another point on your line. I've chosen a couple of points here. I've chosen the one up at the top here. I've taken it on this major grid line. So it's 1, so at least my x coordinate is 1, and I've chosen this one as my y coordinate is 1. trying to make life a wee bit easier for me. So all I really had to do was read off the x coordinate for this one and the y coordinate for this one. There we go. Yeah, I've written them on here, but that's just to make life easy for myself. You don't have to do that. Find your gradient. Now, you're finding the gradient for a reason. So if we look back to the formula they've given us, we can use this to find g. Lots of boys and girls dump values in from the table into here and calculate g, and you cannot do that. This question specifically says in bold here, look, using the gradient from your graph to determine gravitational field strength. So there's two ways of thinking this. The left hand way is the kind of way that's in my head. I'm not expecting you to write the red stuff. That's just to make it a bit clearer what's going on. The story is you've got the formula there, and I've rearranged it into y equals mx plus c. And we saw from the graph that my c was 0. So my y is t squared, my x is L, which means my gradient, look, is 4 pi squared over g, and that is really where you're picking up the story. There's no harm in writing the blue bit at the top, but really this is where you're picking up the story. The gradient is 4 pi squared over g, so you put in your values, do your calculation. There's your 2 marks. It's a 2 mark because of, why is it a 2 mark? Because I've already given you the formula, I suppose. Right, the other way of thinking about it is to look at it this way, just picking up the formula as they had it. Now the gradient is vertical over horizontal, and on the vertical axis they had t squared, and on the horizontal axis they had L. So t squared over L must be the gradient. So the gradient equals 4 pi squared over g, and again you're picking up the story from here, look. You can rearrange for g and get your value for g. Remember, you must use the gradient. It tells you that in bold.